Our planet teems with life. From the smallest microorganisms to the largest mammals, Earth is a vibrant tapestry of living beings. From the deepest oceans to the highest mountains, life finds a way. It thrives in the most extreme environments, from the crushing depths of the ocean to the thin air atop the highest peaks. But what about other planets? Could life exist beyond Earth? This question has fascinated humanity for centuries, driving us to look up at the stars and wonder. The search for life beyond Earth is one of the most profound quests in science. It involves astronomers, biologists, chemists, and many other experts working together to explore the unknown. It speaks to our place in the cosmos and the fundamental question of whether we are alone. Are we a unique phenomenon, or is life a common occurrence in the universe? Planetary habitability is the study of whether a planet or moon could support life. Scientists examine factors like the presence of water, the right chemical ingredients, and suitable temperatures. It's a complex puzzle with many pieces. Each discovery brings us closer to understanding the potential for life elsewhere. We look for worlds similar to our own, planets in the habitable zone of their stars, where conditions might be just right for life as we know it. But we also keep an open mind. Life might surprise us. It could exist in forms we can't even imagine, thriving in environments we would consider inhospitable. The search for extraterrestrial life challenges our understanding of biology and the limits of life itself. It's a journey of discovery that could redefine our place in the universe. One key factor in planetary habitability is the habitable zone, also known as the Goldilocks zone. This is the region around a star where temperatures are just right, not too hot, not too cold. Liquid water, essential for life as we know it, could exist on a planet within this zone. Earth resides comfortably within our sun's habitable zone. Venus, closer to the sun, is a scorching inferno. Mars, farther away, is a frozen desert. The habitable zone varies depending on the star's size and temperature. Larger, hotter stars have habitable zones farther out. Smaller, cooler stars have habitable zones closer in. A planet's atmosphere plays a crucial role in its habitability. It regulates temperature, shields the surface from harmful radiation, and can even provide the ingredients for life. The composition of an atmosphere is critical. Earth's atmosphere, rich in nitrogen and oxygen, supports a diverse biosphere. The greenhouse effect is another important factor. Gases like carbon dioxide trap heat, warming the planet. A runaway greenhouse effect, as seen on Venus, can render a planet uninhabitable. But a moderate greenhouse effect, like on Earth, is essential for life. Water is the lifeblood of our planet. It's essential for all known life forms. We need it to drink, to grow food, and for countless biological processes. The presence of liquid water is a strong indicator of potential habitability. Where there's water, there might be life. We search for liquid water in the solar system and beyond. Mars shows evidence of past liquid water. Europa, a moon of Jupiter, likely harbors a vast subsurface ocean. These watery worlds offer tantalizing possibilities in our search for life. Section 5. Holding it all together. Gravity and atmospheres. Gravity is a fundamental force that shapes planets and their atmospheres. A planet's gravity depends on its mass and size. Larger, more massive planets have stronger gravity. Gravity holds an atmosphere in place, preventing it from escaping into space. A planet with too little gravity, like Mars, struggles to hold onto its atmosphere. This is one reason why Mars has a thin, wispy atmosphere compared to Earth. A planet's gravity is a key factor in its ability to retain an atmosphere suitable for life. Section 6. The protective shield, magnetic fields. Earth's magnetic field is our invisible shield. It protects us from harmful radiation from the sun, known as the solar wind. This radiation can strip away a planet's atmosphere and harm life on the surface. The magnetic field is generated by Earth's molten iron core. It acts like a giant bar magnet, deflecting charged particles from the sun. Without a magnetic field, life on Earth would be exposed to harmful radiation, making our planet much less hospitable. Section 7. The life-giving stars. Stellar influences on habitability. Stars are not just distant points of light in the night sky. They are the very engines that drive the dynamics of planetary systems. Stars are the engines of planetary systems. They provide the energy necessary for life and play a crucial role in determining the habitability of their planets. Without the energy from stars, planets would be cold, lifeless rocks floating in the vastness of space. They provide the energy for life and influence the habitability of their planets. The energy output of a star, its stability, and its lifespan are all critical factors that can make or break the potential for life on surrounding planets. Our Sun, a G-type star, is a stable and long-lived star. This stability has been a key factor in allowing life to evolve and thrive on Earth over billions of years. The Sun's consistent energy output has created a relatively stable climate, which is essential for the development of complex life forms. This stability has allowed life to evolve and thrive on Earth over billions of years. The Earth's diverse ecosystems, from lush forests to arid deserts, owe their existence to the Sun's life-giving energy. Other types of stars, like red dwarfs, are smaller and cooler than our Sun. Red dwarfs are the most common type of star in the Milky Way galaxy, and they have some unique characteristics that influence the habitability of their planets. They have longer lifespans, but emit less energy. This lower energy output means that planets need to be much closer to the star to be in the habitable zone, where liquid water can exist. Planets in the habitable zone of a red dwarf would be tidally locked, with one side always facing the star. This results in one hemisphere experiencing perpetual daylight, while the other is in constant darkness. This could lead to extreme temperature differences between the two sides, potentially impacting habitability. The side facing the star could be scorching hot, while the dark side could be freezing cold, creating a challenging environment for life to develop and sustain itself. Understanding these stellar influences is crucial for our search for habitable exoplanets and the potential for life beyond Earth. Section 8. The building blocks of life. Essential elements and resources. Life as we know it requires certain essential elements. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur are the building blocks of life on Earth. These elements are found throughout the universe, forged in the hearts of stars. The availability of these elements on a planet's surface is crucial. They are needed to form the molecules of life, such as DNA, proteins, and carbohydrates. The search for life beyond Earth often focuses on finding planets with the right mix of these essential elements. Section 9. Finding balance, orbital, and rotational stability. A planet's orbit and rotation also play a crucial role in its habitability. Earth's relatively circular orbit and moderate axial tilt create stable seasons and a relatively constant amount of sunlight throughout the year. Extreme orbital eccentricities or axial tilts can lead to dramatic climate variations, making it challenging for life to adapt and thrive. A planet's orbital and rotational stability are essential for maintaining a habitable environment over long periods of time. Section 10. The search continues. Challenges and the significance of finding habitable worlds. The search for habitable worlds is a daunting task. The universe is unimaginably vast, with billions of stars in our galaxy alone, each potentially hosting its own planetary system. The vast distances between stars make it incredibly difficult to directly observe exoplanets, as they are often obscured by the brightness of their parent stars, let alone determine their habitability. Advanced telescopes and observatories are crucial in this quest, but even they have their limitations. We rely on indirect methods, such as observing the wobble of a star caused by the gravitational pull of an orbiting planet. This method, known as the radial velocity technique, has been instrumental in many exoplanet discoveries. Despite the challenges, we have discovered thousands of exoplanets, each one a potential candidate for further study. These discoveries are made possible by the dedication and ingenuity of scientists and engineers. Some of these exoplanets show tantalizing hints of potential habitability, such as being located in the habitable zone of their star, where conditions might be right for liquid water to exist. These discoveries fuel our imagination and inspire us to continue pushing the boundaries of our understanding. The possibility of finding a world that could support life is a powerful motivator for ongoing research and exploration. Finding evidence of life beyond Earth would be a profound discovery, one that would have far-reaching implications for science, philosophy, and our understanding of our place in the universe, forever changing our perspective on our place in the cosmos. It would challenge our assumptions about the uniqueness of life on Earth and open up new avenues of inquiry about the nature of life itself. The search for habitable worlds is not just about finding another Earth. It's about understanding the diversity of planetary systems and the potential for life in the universe. Each discovery brings us one step closer to answering the age-old question, are we alone? As technology advances, so too does our ability to detect and study these distant worlds. Future missions and next-generation telescopes promise to reveal even more about the planets orbiting other stars. International collaboration and the sharing of knowledge are key to overcoming the challenges we face in this endeavor. By working together, scientists from around the world can pool their resources and expertise to make groundbreaking discoveries. Inspiring the next generation of scientists and explorers is also crucial. Educational outreach and public engagement help to foster a sense of wonder and curiosity about the universe, encouraging young minds to pursue careers in science and technology. The search for habitable worlds is a journey that will continue for generations to come. It is a testament to humanity's enduring quest for knowledge and our desire to explore the unknown. As we look to the stars, we are reminded of the boundless possibilities that await us in the cosmos.
Like and subscribe to start your journey today.